All mixtures can be classified in two different ways. We have forms of mixtures and types of mixtures. This is Learner's Aid, where scholars are made. Have you ever poured sand into water, stirred it, and then waited for some time for the sand to settle at the bottom? Have you ever done that before? What about this? Poured sugar or salt into water, stirred it, and magically the salt or sugar disappeared in the water and it appears as though there is no salt or sugar in it until or unless you taste it. Have you ever experienced or done any of this before? I'm sure you have. Now here's the big question. These two things I've described, sand in water and sugar or salt in water, are these two mixtures? What do you think? Are they described as mixtures? I'm sure you've gotten the answer. What about this? Milk. When you look at milk, it looks smooth, but you can tell that it's hiding something. What about water and oil? Water and oil are both liquids, but they refuse to mix. And then finally, we have air. Air is described as a mixture of gases. You can't see it, but it is considered as a mixture. So tell me, is milk a solution? Milk, is it a solution? What about sand and water? The combination of sand and water, is it the same kind of mixture as salt and water? Would you describe a mixture of sand and water as the same kind of mixture as salt and water? What about when you face or meet this kind of question in the exam where they say classify mixtures and then automatically you get confused? You see, here's the truth. Most students do not fail questions on mixtures because the questions are difficult. Because if you take the past questions that have been coming all this while on mixtures, there is no way you will tell me that questions on mixtures are difficult. So students fail exam on mixtures not because the questions on mixtures are difficult. No way. They fail because they do not know how to think about mixtures. That is the main problem. And we are going to fix this problem in this lesson. So by the end of this lesson, you will be able to do this. You will never ever confuse solid liquid and liquid mixtures again. You will be able to explain this with confidence, and you will know exactly when to say solution, suspension, and colloid. You will get to understand the clear-cut difference that exists between these three unique or special types of mixtures. And then you will understand the difference between homogeneous and heterogeneous mixtures as if it is common sense. And then finally, you'll be able to answer BECE mixture questions with confidence. So these are some of the things we'll be tackling in this lesson. So let's get right into business. Let's start from the very beginning. What is a mixture? What is a mixture? If you see the definition on the screen, we said a mixture is what is formed when two or more substances are put together without any chemical change. It is what is formed when two or more substances are put together without any chemical change. That is so important. So when you combine two substances physically without any chemical change, what is formed is a mixture. If a chemical change occurs, there is no more a mixture. It's now described as a compound. But the focus of this lesson is basically on mixtures. So that is the definition we have out there. And we have some examples here, sand and salt. So a mixture of sand and salt, a combination of sand and salt is a mixture. A combination of sugar and water is also a mixture, like you see in the animation down there. So you can see that a spoon of salt is poured into the water and then the salt disappears in the water. So that is a mixture. and we have oil and water. It's also an example of a mixture. So if you combine two or more things physically without any chemical change, then you have a mixture. And then there is this main point. Each substance in a mixture keeps its original properties and can be separated by physical methods. What does that mean? Let's take an example of sand and salt. If you look at sand and salt, if you mix sand and salt, the sand doesn't change to become something new, or the salt doesn't change to become something new. And I think a more vivid example would be, let's say, rice and beans. It's also a mixture. So if you mix rice and beans, what is formed is a mixture. But the fact is, the rice in this mixture is still rice, and the beans is still beans. It doesn't change. That is what we mean by the substances in a mixture keeps its original properties. So if you have oil and water forming a mixture, the oil is still oil, and then the water is still water even after mixing them. The individual components do not change. That is why they can be separated by physical methods. So keep that in mind. That's one unique thing about mixtures. So in 2014, there was a BECE question number 15. An example of a mixture is. So you have these options: hydrogen chloride, that is HCl, sodium sulfate, salt solution, and ammonia. Out of these options, it is obvious that salt solution is the answer, because if you look at the previous page, we said an example of a mixture is the combination of salt and water. So if you pour salt into water and stir it, and the salt dissolves, the salt is still in the water and it can be retrieved back. So that is an example of a mixture. But the remaining options here: hydrogen chloride, sodium sulfate, and ammonia, all of these are compounds. All of these are compounds. They are elements that have been combined. And if you look at hydrogen chloride, there is hydrogen and chlorine now there. After the two of them have combined, this happens as a result of chemical combination. So it's not a mixture. The same thing applies to the remaining options that are not the answer. So the answer for this particular question is salt solution. This same question, that is an example of a mixture, is this same question or a similar question was asked in 2017, 2008, 97, 95, and 92. So you can see that this kind of questions seem to be repeated over the years. And then it can also be repurposed into section B question. So keep that in mind. Now let's classify mixtures, classification of mixtures. All mixtures in this world can be classified in two main ways. We can classify mixtures based on the state of matter that are mixed. Based on the state of matter that are mixed. Or based on how well the substances mix. So based on the state of matter that are mixed is what is referred to as the forms of mixtures. And based on how well the substances mix is what is referred to as the types of mixtures. We'll be looking at that in some few minutes. So when it comes to classification of mixtures, the criteria can be stated. So if you are asked to classify mixtures and the criteria is stated, that is classify mixtures based on the state of matter that are being mixed, or classify mixtures based on how well the state of matter mixed, then you should know what to do. We'll be explaining that soon. So let's pick the very first one. But before we go there, pay attention to this main point here. These two styles or ways of classifying mixtures are different but connected. They are different in some aspects, but they are quite connected. When we pick them one after the other, we'll explain that. So let's pick the very first one. Classification by states. Classification by the state of matter that is being mixed. That is what is referred to as the forms of mixtures. So what are the forms of mixtures? You see, this basis of classification answers a vital question. what states of matter are mixed. So based on answering these questions, we have some types of mixtures or some forms of mixtures. Let me put it that way. For the first one, we have solid-solid mixtures. So remember the question, what states of matter are mixed? So that's the question we want to answer. So if to find an answer to that question, that is forms of mixture, the first form of mixtures we have is solid-solid mixtures. For this, you have two or more solids mixed together. Two or more solids mixed together. And examples are the combination of sand and salt, rice and beans, iron filling and sand. This is a typical example of a form of mixture, not a type of mixture. So keep that in mind. I'm stressing on this point because there are a lot of textbooks out there that confuse students a lot because there's a broad topic, types of mixtures, and then they list solid mixtures, liquid mixtures, and then they mention some other example like homogeneous and heterogeneous, which we'll be looking at very soon. But the first form of mixtures we are considering the solid mixtures like we've discussed. The next example is solid liquid mixtures. Solid liquid mixtures. For this type of mixtures, solids are mixed with liquids, or a solid is mixed with a liquid. For example, you can have a salt and water. So you have salt solution. Or we have sand and water, or sugar and water. All of these are solid liquid mixtures because you have a solid mixing with a liquid. Then we have a solid gas mixture. For that, we have solid particles mixed with gases. And examples, we have smoke, dusty air, volcanic ash, and air. These are some examples of solid gas mixtures. And then, interestingly, in 2014, there was a question to that effect, question number 15, 2014. There was this question: which of the following substances is a solid gas mixture? Which of them is a solid gas mixture? What do you think? Is it leather or bronze or steel or smoke? Obviously, the answer is smoke. So smoke is a solid gas mixture. We have solid particles dispersed in gas. So the answer is D. The next form of mixture I'll be describing is liquid-liquid mixture. Liquid-liquid mixtures. For this, we have two or more liquids mixed together. Two or more liquids mixed together. For that, we have examples as water and oil, water and kerosene, water and alcohol. These are all liquids. So if you have two or more liquids and just boil them together and mix them together, I have a liquid-liquid mixture. As simple as that, right? Then we have finally gas-gas mixture. For gas-gas mixture, we have two or more gases mixed together. An example is air. No wonder for a very long time when we ask to define air, we say air is a mixture of gases. Air is a mixture of gases. So air is an example of a gas-gas mixture. And what are some of the gases that make up air? We have oxygen, nitrogen, and carbon dioxide. So remember, these are forms and not types of mixtures. So when it comes to the forms of mixtures that we've described, it focuses on the state of matter that are mixed. So that is one way of classifying mixtures. So if you are asked to classify mixtures and you are given the criteria for classification, for example, based on the states of matter that are being mixed, then you can mention these examples. But most often than not, they really do not specify. They just tell you classify mixtures. Then that you have the liberty to choose the style of classification you want. When it gets to the question aspect, we will explain that into detail. So far, so good. We are done with classification by state of matter that have been mixed. Now let's look at classification by how well this state of matter mix. You see the criteria for classification in this side. We have classification by how well they mix. That is what is referred to as the types of mixtures. So for this style of classification, it answers a very important question. Can the different parts of this mixture be seen? After you mix salt and water, after mixing it, can you see the different parts? Can you see the salt? Can you see the water? Or when you mix rice and beans, can you still see the beans? Can you still see the rice? So you are trying to answer this question. Can the different parts be seen? That is the base for classification. Classification by how well they mix. For that is what is referred to as types of mixtures. For that, we have two main types of mixtures: homogeneous mixtures and heterogeneous mixtures. Homogeneous and heterogeneous mixtures. These are the true types of mixtures. But the solid, liquid, liquid, gas are the forms of mixtures. So now that we've seen the types of mixtures, let's pick them one after the other. First one, homogeneous mixtures. What are they? So these are mixtures that have a uniform appearance throughout, or uniform composition throughout. What does that mean? It basically means that after forming a homogeneous mixture, the individual components cannot be seen separately. For example, we have salt solution, that is, or sugar solution. If you look at the little animation down there, let's assume that is salt or sugar. So if you pour the salt or sugar in water and you stir and the salt or sugar dissolves, you will not see the salts in the water. It will appear as though it's just water in the container or cup. So if you look at the picture, as the salt dissolves, it appears very transparent as it was before the salt was poured into it. But does that mean the salt is not there? No, it doesn't mean that the salt is still there. But here's the point. You cannot see the individual components of this mixture as separate components. It just looks as it's now having a uniform appearance throughout. So that is what we refer to as a homogeneous mixture. And for example, we have air, salt solution, sugar solution, and a mixture of alcohol and water. If you mix alcohol and water, what will be formed will be uniform. So as we spoke about air earlier, I have different gases in it, but they have been mixed so uniformly that it feels as one whole unit. So keep that in mind. That is a homogeneous mixture. Now let's talk about heterogeneous mixture. For this is the opposite of homogeneous. For heterogeneous mixtures, the mixtures do not have uniform appearance. So these are mixtures that have non-uniform appearance. What that basically means is that after mixing the component, you can see them separately. That is basically what it means. After mixing them, for example, we have water and sand. If you mix water and sand, the sand is never ever going to dissolve in the water. Even after leaving it for some time, the sand will settle, and then you can still see the water and see the sand. So this is a heterogeneous mixture because the individual components can still be seen. And then we have gravel and sand, rice and beans, rice mixed with beans. You can still see the rice and you can still see the beans as separate components that have been mixed. So that is heterogeneous mixtures. Water and oil. If you look at the picture out there, you can see that the oil is on top and the water is down. So they have not uniformly mixed. That makes it heterogeneous mixture. Now we have this unique type: solutions, suspensions, and colloids. Remember I said earlier that there are two main ways of classifying mixtures through the two main criteria, either based on the state of matter that are being mixed or by how uniform the state of matter mixed with each other. And for how the state of matter that are being mixed, we have solid, gas, liquid, and cool. And by how well they mix with each other, we have homogeneous and heterogeneous. There is a third way of classifying, but we put that as a unique way of classifying mixtures. So this describes how the particles behave when one substance is dispersed in another. That's also another criteria we can base on, but for this level, we only spoke about the two ways of classifying them. So solutions, colloids, and suspensions are also one unique way of classifying mixtures based on how, after mixing them, how the particles disperse in each other. That is one criteria. So we'll pick them one after the other. So let's pick the first one, solution. For solution, it is described as a homogeneous mixture in which one substance, which is often described as the solute, is completely dissolved in another, that is the solvent. So a solution is a uniform mixture or a heterogeneous mixture in which a solute completely dissolves and disappears entirely in a solvent. For example, we have salt and water. So for salt and water, which is a solid liquid mixture, so you can see that if you pick one example, remember earlier we said the classifications are different but connected. This is what we mean. So salt and water is an example of a solid liquid mixture, and at the same time it is a homogeneous mixture and then a solution. So pay close attention to that. If you pick salt solution is salt and water is a mixture that specifically falls under solution. Why? Because the salt completely dissolves and disappears in the water, and then we have a uniform mixture. And then it is solid liquid because salt is solid and water is liquid. So pay close attention to that. And then we have ammonia and water, which is liquid, and air, which is a gas in gas mixture. So these are examples of solutions. So the key point, the solute completely disappears in the solvent. We'll be looking at some characteristics and you will get that soon. So these are some of the characteristics of solutions. It is uniform throughout. So if you look at the salt solution on the screen, that's little animation. As you pour the salt in the water and the salt dissolves in the water, you realize that the salt disappears. And then the final solution that is formed is uniform throughout. Unless you taste it, you wouldn't know. You think it's just plain water with nothing placed in it. So it is uniform throughout. That is one unique characteristic of solutions. After mixing the two stuffs, you have one uniform solution that has been formed, or one uniform mixture is formed. And then the next property of or characteristics of solution is that the particles are very small. So if you look at salt and water, the particle of salt, after it dissolves in water, it becomes so small that we cannot see it. That is why it appears to have a uniform composition throughout. And then the next property is the particles do not settle. If you put salt in water or sugar in water and stir, and the salt or sugar dissolves completely, and there's that uniform mixture that's formed, if you leave it down for some time, the salt is not going to settle at the bottom. It will still remain as uniform as it was from the beginning. That's one interesting thing about solutions. So that's why we said how the particles disperse when they are mixed together. Remember we said a solute mix in solvent to form solution. We have types of solution. And the types of solutions we'll be discussing in this part are two: saturated and unsaturated solution. For saturated solution, this is the type of solution that no more solute will dissolve at a particular temperature. This is what it means. So you have salt and water. You keep adding salt. You stir, the salt dissolves. You add the salt. You stir, the salt dissolves. This is what is happening. As you keep adding the salt and the salt keeps dissolving, a time will reach, you will reach a level where you keep adding salt and the salt will then dissolve again. What that means is that the water has reached its limit. It cannot dissolve any more solutes. So when you reach that level where the solution cannot dissolve any more solutes at a particular temperature, then we have a saturated solution. So you can think of it like a container and you are filling it, and then the container, maybe you are filling the bowl with rice, and then the rice has gotten to the brim of the bowl. You can add more rice. So it's fully saturated. That is what you mean by saturated solution. No more solute will dissolve. And the opposite is unsaturated solution. For unsaturated solution, the more solutes can dissolve simply because it doesn't reach its maximum dissolving capacity. So there's more room for dissolving the solutes that you'll be adding. So that's the unique difference between saturated and unsaturated solutions. So in 2005, there was a question number 21. A solution in which no more solutes will dissolve at a given temperature is said to be interesting, right? A solution in which no more solutes will dissolve at a given temperature is said to be what? It's said to be saturated. It's said to be saturated. For concentrated, why do we say concentrated is not the answer? Concentrated solution is basically a solution that has more solutes in it. That's more solutes. So you have some amount of water and add more salt. The more salt you add, it becomes concentrated, highly concentrated. And if you keep adding, then it moves from being highly concentrated to becoming saturated. So when you're forming a solution, you add, it has to get to highly concentrated before it moves to saturated. And for dilute, that means the solute in there is small. I already know what homogeneous is. You see, this particular question that was asked in 2005, this same question was asked in 2001. So why do I keep bringing these things up? I just want you to know that questions do not come from space. Even if they've introduced a new syllabus, this is the fact. They're not going to pick questions from anywhere. It's still going to be these old questions that will be restructured to look new. Even if the question is completely restructured, the same idea is carried. So understand the topic and solve more past questions. No matter how the question is framed, you have an idea about what to do. Let's continue with suspension. So we are done with solution. So as a recap, for solution, the solute dissolves in the solvent. And then what happens is that it disappears completely and there's a uniform composition throughout, to the level that you will not be able to even see the solute that has dissolved. What about suspension? A suspension is a heterogeneous solid liquid mixture. Heterogeneous solid liquid mixture in which the solid does not dissolve and settles when left to stand. For example, we have muddy water and powdered chalk in water. So for powdered chalk in water is the same as powdered charcoal in water. So pay attention to that. So powdered chalk in water or powdered charcoal in water. If you grind chalk or charcoal, you pour it in water, you shake it, you form a suspension. Because there is no way this powdered chalk or powdered charcoal will dissolve in the water. It will never happen. It will never ever dissolve in the water. So the powdered chalk or powdered charcoal will never dissolve in the water. It will remain dispersed in the water and you can see it. You can see the particles of the chalk or particles of the charcoal in the water. And then if you put this mixture down, a mixture of maybe powdered chalk in water, if you put it down after some time, you realize that all the powder will now settle at the bottom. The same thing applies to muddy water. So because the powdered chalk or powdered charcoal will not dissolve in the water and will settle when you put it down after some time, this kind of mixture is known as a suspension. And since it is not uniform throughout, it is also a heterogeneous mixture. And powdered chalk and water is also a solid liquid mixture. So when it comes to classification of mixtures, I repeat, there is always a criteria for classification. At this level, basic education level, most of the textbooks use classification loosely. They say classify, they don't really tell you the basis for classification. But I want you to know that there are bases for classifying. But most often, the exam questions will not specify the criteria for classifying. For that, it's easy. But pay attention, you never know. Maybe a time will come where it to be specified, classifying mixtures based on the state of matter that are mixed. They have solid, solid, liquid, liquid. Or classify based on how well the individual particles mix with each other. They have homogeneous and heterogeneous. Or classify them based on how the particles disperse in each other. They have suspension, colloid, and solution. So pay attention to that. But if they've not specified the criteria for classifying, then you are free to mention any of the examples I've given you. So pay attention to this point. A suspension is mainly a solid liquid mixture, because the solid must be there dispersed in the liquid and to not dissolve like the particles of a grounded charcoal or chalk, and to settle after some time. What are some characteristics of suspensions? Characteristics of suspension. For the first one, the particles are visible. So if you pour powdered charcoal or powdered chalk in water and you mix it, you still see the individual particles in there. You completely see them, and after some time they will settle. The same thing applies to muddy water. And the next thing is, can be separated by filtration. If you pour powdered charcoal or powdered chalk in water, you stir it or you mix it, and then you leave it to set for some time. Even without leaving it to set for some time, if you get a filter paper and a funnel, you can separate the two by means of filtration. But if you look at the solution, that's one interesting difference between solution and suspension. For the solution, if you pour salt in water and you stir and completely dissolves, you can't separate by filtration because they will all pass through the filter paper. That's one interesting difference. And then finally, when you leave suspension for some time, the particles will settle. They'll settle at the bottom. That's one point you should keep in mind. Finally, we have colloids. Colloids. So a colloid is a mixture in which very tiny particles are spread evenly in another substance and do not settle. It's kind of like looking like the definition of suspension. You see, for the colloid, the particles are tiny and they spread out, but they do not settle even after putting them down for some time. So look at this. The particles of colloids are larger than those in a solution. You see, solution, the particles completely dissolve. You cannot see them. Colloid particles are larger than the particles of solution, but they are smaller than the particles of suspension. So there are some textbooks out there that say colloid is an intermediate between solution and suspension. Colloid is an intermediate between solution and suspension, meaning it's in between. Its particles are bigger than solution, but smaller than suspension, and they won't settle. And the particles are evenly distributed, they remain like that. So for example, we have milk. If you look at milk, milk looks as though it is homogeneous and the individual, like it looks like one complete uniform mixture throughout. But the truth is this, we have these particles that are evenly spread inside and they won't settle. So that's a unique example. Milk. Milk is a liquid mixture. Smoke, and we have fog. These are examples of colloids. Now let's talk about some properties of colloids. Properties of colloid. The first property is the particles of colloids are too small to see with the eye. They are too small and we cannot see them with the eye. And the next property is they cannot be filtered. So you can't just pick milk and knowing that milk is a colloid, there are some particles dispersed in it, so you just take filter paper and you filter the particles out. It's not possible, so they cannot be filtered. And then finally, colloids appear to be uniform. For example, the milk that we spoke about, it appears to be uniform throughout, but it is actually heterogeneous. So that's one interesting thing about colloids. To keep that or these properties in mind. Now we've gotten to one unique or specific type of colloid known as emulsion. Emulsion. So emulsion is a specific type of colloid. What does that mean? You see, in an emulsion, two normally immiscible liquids. When we say immiscible, meaning the two liquids cannot mix together. They can't mix. That's what you refer to, immiscible liquids. So in emulsion, two normally immiscible liquids like water and oil are dispersed within each other. This is what it means. If you look at the image on the screen, we have oil and water. Oil and water are immiscible liquids, meaning they cannot mix. So even after pouring the oil on the water, you would see that the oil is still on top of the water and the water is down. They will not mix. This is not an emulsion. No. They are just two immiscible liquids, one on top, one on the bottom. But immediately you stir them and shake or agitate them over some time, or after some time, the water and the oil will now form an emulsion, which is a specific type of colloid. Which is what? A specific type of colloid. So an emulsion is a type of colloid that is formed from two immiscible liquids. So an emulsion must involve, this is one unique difference about emulsion, and emulsion is a type of colloid. So colloid is a larger umbrella, and a certain type of it, a specific type of it is emulsion, as long as there are two immiscible liquids. So an emulsion involves two liquids, whereas a colloid can involve any combination of states. You can have solid in liquid or gas in liquid. So interestingly, in 2001, question number 35, there was a question like that. When oil and water are shaken together, they form a mixture called, so now the mixture has a unique name. And the answer is what? An emulsion. So you see that they've not brought colloid over here. When immediately they bring colloid, it becomes confusion. Good, because emulsion is a type of colloid. But I think if they even bring colloid, you should go for emulsion. Because this question is very specific. Oil and water, you shake them together. If you shake, then a mixture that will be formed is what? Emulsion. Let's talk about solutes and solvents. Perhaps maybe our last subtopic, maybe. Solute and solvent. For that, a solute is a substance that dissolves in other components of a mixture, like the solvent. So a solute dissolves in a solvent, basically like that. So a solute, any substance that dissolves in another component of a mixture is a solute. And a solvent is the component of the mixture that dissolves other components. And the components that dissolve are the solute. So take note of this. Water is considered as what? A universal solvent, because it dissolves almost all solutes. That is why water is considered a universal solvent. It dissolves almost all solutes, not all. It dissolves a lot of solutes. That is why water is considered a universal solvent. And note, look at the definition of a solute and solvent. It said a solute is a substance that dissolves in other components of a mixture. And a solvent is the component of a mixture that dissolves other components. So a solute dissolves in a solvent, and a solvent dissolves a solute. So in normal sense, the substance which is often present in the largest amounts that holds other substance is considered a solvent. So if we have two substances, the one that appears to be the largest and other substances are inside, the largest of them all is considered the solvent. You understand this from this past question. Just recently, 2024, question number 6. And here's the question. The portion of air which acts as a solvent is what? If you look at this question, the portion of air is a mixture of gases. We have oxygen there, nitrogen there, carbon dioxide there, and some rare gases out there, or inert gases out there. So oxygen, nitrogen, carbon dioxide, and inert gases. This mix to form air. Now they are asking you which of these gases is acting as a solvent. So that means gases can also act as a solvents. That's basically what it means. And remember this point, the one that happens to be the largest in the bunch ends up being a solvent. And we know that nitrogen is almost 78%. So there are like 78% of nitrogen in air. And it is the largest. The rest are tiny. We have 21 for oxygen, 0.0 something for carbon dioxide. So you see, since nitrogen happens to be the one more abundant than the rest, it's taken to be the solvent of air. Interesting point to take note of. Now let's compare solutes and solvent. In this, we mean some specific solutes and their suitable solvents. That's what you have on the screen. So common salts can dissolve in water. Oil paint can dissolve in kerosene, turpentine, or petrol. Coal tar can dissolve in kerosene, turpentine, petrol. Ink stain can dissolve in milk or alcohol. Chlorophyll can dissolve in alcohol or organic solvent. Grease can dissolve in kerosene or petrol. Alcohol can dissolve in water. So this is a possible past question, and this question has also appeared before. So there they will give you some substances and you'll be asked to write the suitable solvent that those substances can dissolve in. So take note of this table, pay close attention to it. So in conclusion, let's pick some past questions to wrap up. The first past question, question number 1. Question number 1. 2005, question 23. Water is sometimes referred to as a universal solvent because why? Why is water considered a universal solvent? And here's the answer. It dissolves most substances. It dissolves most substances. Next question. Steel is an example of what? Steel is an example of a solid in solid mixture. So that is basically an alloy, combination of metals. So steel is an example of a solid in solid mixture. They have which of the following solvents can be used to remove grease from the hand. So it basically means which of these can grease dissolve in, and the answer is turpentine. Turpentine. Good. So grease dissolves in turpentine. Then we have, if a mixture of water and powdered charcoal is allowed to stand for a long time, what will happen? The charcoal will settle at the bottom. The charcoal will settle at the bottom. In the explanation, we actually explained that extensively in the explanatory part of this lesson. Then we have this. The solvent which is most effective in washing bitumen from the hand is, it means which of these can dissolve bitumen? And the answer is kerosene. Kerosene can actually dissolve it. Now let's pick a section B question. Classify a mixture of each of the following pairs of substances as either homogeneous or heterogeneous. Classify them. You have oil and water. Is it homogeneous or heterogeneous? You have salt and water. We have ethanol and water. So this is the answer. So for each pair, if you mix water or oil and water, if you mix them, you have a heterogeneous mixture. If you mix salt and water, you have homogeneous. If you mix ethanol, ethanol is the same as alcohol. If you mix alcohol and water or ethanol and water, you are going to have a homogeneous mixture. This question came in 2025. 2025. Another 2025 question is this. Just recently, consider the following mixtures: air and vinegar. Air is essential to life. Vinegar is a common household substance. So name the two major components of each mixture. Name the two major components of each mixture. And then which of the following component is in I acts as a solvent in each of the mixtures? For our answers, for the first one, I, name the two major components. Name the two major components of each mixture. For air, the two major components are nitrogen and oxygen. They are the most abundant, these two. And then for vinegar, the two major components are ethanoic acid and water. Now for the next part of the question, which of the components named in I acts as the solvent? Remember, for air we mentioned nitrogen and oxygen. Nitrogen is the solvent. For vinegar I mentioned ethanoic acid and water. Water is the solvent. So these are some interesting questions to wrap up the lesson. Now there is an assignment for you. 2022 and 2020. You can check up the answers in these past questions. For the first one, briefly explain why air is regarded as a mixture. Air is not considered as a compound, but as a mixture. Why? Why is air considered as a mixture? So you can check up the answer. You can leave the answer to this question in the comment section. But think about it this way. Mixtures can be separated physically. Basically physical combinations, so it can be separated physically. You check up the answers and you can leave your answer in the comment section. And 2020 question 6D, state two classes of mixtures. This is what I've been talking about. State the two classes of mixtures. This question is very loose. Yes, to be frank with you, the question is too loose. Or for this level, I think it's okay. Yes, it's easy and fair to you. State the two classes of mixtures. For this classification, it has not been specified. They've not told you whether you are classifying based on the state of matter that are mixing, or based on how well they mix, or based on how the particles disperse. So for this, you are at liberty to mention whether solid-solid mixtures, liquid-liquid mixtures, liquid-gas mixtures, or homogeneous mixtures, heterogeneous mixtures, or mention suspension, colloid, or solution. You are at liberty to mention them, but one advice for you. If you meet this kind of question that is state the two classes of mixtures, if you pick one criteria, mention the examples from that criteria. For example, if you want to go for homogeneous and heterogeneous, go for homogeneous and heterogeneous, two types. Or you can go for liquid-liquid, solid-solid, or liquid-gas, like pick them in pairs, or suspension and colloid. And then you're on the safer side. And the next question is to classify each of the following substances under the classes stated. Classify them under the classes stated. So if you go for homogeneous, if you go for solid-solid, whatever it is bronze a solution? Is bronze solid-solid or liquid-liquid? So based on the type or class that you have mentioned in I, then you put the two examples under each of these classes. So you can check up the answers in this year that I've stated. Yeah. So thank you for watching. This is Learner's Aid. Thank you for learning with us. This is quite a lengthy lesson. For our next lesson, we'll be looking at separation of mixtures. So it's a continuation of this particular lesson. So we are done with understanding what mixtures are, the examples of mixtures, and the way mixtures can be classified. We also looked at solute, solvent, and we look at some specific unique types of mixtures. Now, how can these mixtures be separated? That will be the focus of our next lesson, which is actually a continuation of this particular lesson. So see you in our next lesson.